I've always been interested in what's out there and understanding the universe and how it works, how it formed. Today, one of the newest things that astronomers have found in the universe are these exoplanets, so planets that are beyond our solar system. It is fascinating to think that the solar system we are in may not be unique, that there are many of them and that they are very different. There have been more than 4,000 exoplanets discovered, and with the improvements in technology, there are many more that are being discovered every day. The planets that have been found are very different. The planets are bigger or smaller, and they may have a very different composition. And so it is very important to try to grasp their properties a little bit better, ultimately to see if any of those planets could be habitable. So high pressure physics is the study of the properties of materials under high pressure, meaning pressure exceeding those that are found on the surface of the Earth. I try to understand how materials behave at the pressures and temperature conditions existing within planets. And so what I mostly study are minerals and iron compounds and water ices that are believed to be the main constituents of planetary bodies. In my research, I use giant lasers to compress and simultaneously heat materials to high pressures and high temperatures. And then we use additional lasers to generate bright X-ray sources that are used to take a snapshot of the materials. We can tell if the material is still solid, if it is liquid, and if it has undergone phase transitions, which means if it had changed, if the atoms arrangement has changed. A super-Earth is a planet that is bigger than the Earth and that is expected to have a terrestrial composition. What we have found is that at the pressures and temperatures expected in large extrasolar planets, the properties of these materials are very different from what they are within the Earth. They undergo phase transitions that do not happen within the Earth. That has a dramatic effect on the planetary interior structure and on the planet properties. What it tells us is that the fact that we see a super-Earth beyond our solar system and that super-Earth is in the habitable zone, which is defined as the distance from the star that allows for water to be liquid, it doesn't necessarily mean that that planet is habitable. Just because if it is too big or too small, their interior structure may be completely different. So that generates a planet that is very different from the Earth.